Hello viewers, in the last lecture we have put the concept of exponential and circular function of complex quantities. In this lecture we will discuss some numerical question and solved example based on exponential and circular function of complex quantities. So first example is to separate real and imaginary parts of these two questions. First is e raised to power 6 plus 5 iota whole square, and the second is e raised to power x minus iota y whole square. So we have to separate the real and imaginary part of these complex numbers. Okay, so let's start the solution of the first part. Now what we have to find out, we have to express this number as a new complex number a plus iota b, and we have to find out the value of a and value of b, that is real and imaginary part. So first you have to simplify the power of e, that is 6 plus 5 iota square. You have to simplify this quantity. So open the square. Okay, plus 5 iota square plus 2 into 6 into 5 iota. So this will be 36 minus 25 plus 60 iota. Okay, so this turns out to be 11 plus 60 iota. Now substitute the value of this complex number in this function. Okay, so this will be e raised to power 11 plus 60 iota. Okay, now you can rewrite this as e raised to power 11 and e raised to power iota times 60. Okay, so this is equal to e raised to power 11. You can write this as cos 60 plus iota sine 60. Okay, because we know that e raised to power iota theta is nothing but cos theta plus iota sine theta. Okay, so we are using this here. Now you can open the bracket, e raised to power 11 times cos 60 plus iota e raised to power 11 times sine 60. Now express this. Now this is real part and this is imaginary part. So you can express this quantity as a plus iota b, where a is the real part e raised to power 11 cos 60 and b is e raised to power 11 sine 60. So this completes the solution of first part. So now we move to question number B part of the question. In this question also we have to separate real and imaginary part. So this question is also very similar to the previous one. So what we have to do, first we have to open this square. So this will be x square plus iota y square minus 2 times x iota y. So this will be x square minus y square minus 2 iota xy. Okay, so put this value in this expression. Square is equal to e raised to power x square minus y square minus iota 2xy. So you can write this as e raised to power x square minus y square into e raised to power minus iota 2xy. Okay, now write this as x square minus y square e raised to power minus iota theta, that is cos of 2xy minus iota sine of 2xy. Okay, Now you can open this as x square minus y square times cos 2xy minus iota e raised to power x square minus y square sine 2xy. So this can be written as a plus iota b, where what is the real part? Real part is a e raised to power x square minus y square times cos 2xy, and what is b? B is minus e raised to power x square minus y square sine 2xy. So this is the separation of real and imaginary part for this question. So let's discuss one more question of this type. In this question we have to again express this expression as a plus iota b. It means we have to separate real and imaginary part. So again in this question, first you have to simplify this divided by x plus a plus iota y. So when complex numbers are in numerator and denominator, the best way is to rationalize this one. Okay, so we rationalize this x minus, so x plus a minus iota y divided by x plus a minus iota y. Okay, now simplify this. X minus a into x plus a minus y square plus iota y into x plus a minus iota y x minus a, and in the denominator but we have x plus a whole square minus iota y whole square. First we simplify the numerator. So in the numerator first we have x square minus a square iota y square. This will be y square because iota square is minus 1 and this minus get plus. Okay, so plus iota yx plus ay minus yx plus ay divided by x plus a whole square plus y square. So you can cancel yx with yx. Okay, so what you are left with x square minus a square plus y square is the real part in the numerator plus iota 2ay and divided by x plus a whole square plus y square. So you can write this as x square minus a square plus y square divided by this quantity x plus a whole square plus y square plus iota times 2ay divided by this quantity x plus a whole square plus y square. Okay, so you can write this as r plus iota s, where r is this portion and s is this portion. Okay, so now put this as e raised to power r plus iota s, and you can write this as e raised to power r into e raised to power iota s. Okay, you can write this as e raised to power r cos s plus iota sin s. Okay, now you can back substitute the value of r and s. So what is first we write this in this form, e raised to power r cos s plus iota e raised to power r sin s. So this will be imaginary part and this will be real part. So you can write this as a plus iota b. You have to describe the value of a and b. Is a here? A is e raised to power r, e raised to power r, and what is r? X square minus a square plus y square divided by x plus a whole square plus y square. So this will be a, because a is e raised to power r, and then cos s. S is 2ay over x plus a whole square plus y square. Okay, and what will be b here? B is e raised to power r x square minus a square plus y square divided by x plus a whole square plus y square, and then sine of s, and s is 2ay over x plus a whole square plus y square. So this is the representation of the given question in forms of a plus iota b. It means we have separated the real and imaginary part. Okay students, so let's move to question number 2. So open the left hand. To solve this question, you have to first open the left hand side. So what is left hand side? Sine alpha minus theta plus e raised to power plus minus iota alpha sine theta whole raised to power n. Okay, so if you rewrite sine alpha minus theta plus e raised to power plus minus iota alpha sine theta raised to power n. Okay, so you can open this as apply sine alpha minus theta formula, sine a cos b minus cos a sine b. Okay, and you can use e raised to power iota theta as cos alpha plus iota sine alpha, and for the negative side you can rewrite this as cos alpha plus iota sine alpha and cos alpha minus iota sine alpha multiplied by sine theta raised to power. Okay, now simplify this. Sine alpha cos theta minus cos alpha sine theta. Okay, if you open this round bracket, you will have cos alpha sine theta plus minus iota sine alpha sine theta whole raised to power n. Okay, now cancel the terms, cos alpha sine theta, cos alpha sine theta. So what you are left with, sine alpha cos theta plus minus iota sine alpha sine theta raised to power n. Okay, now you can take outside common, sine alpha raised to power n. Now what is the inside? Cos theta plus minus iota sine theta raised to power n. Now you can use DeMoivre's theorem. Sin n alpha, apply DeMoivre's theorem, that power n goes into the angle cos n theta plus minus iota sin n theta. Now according to the requirement, you have to move one power inside, because you require sin n minus 1 alpha outside. So move one power inside, sin n minus 1 alpha, move sin alpha inside, sin alpha cos n theta plus minus iota sin alpha sine n theta. Okay, so what we will do next, sine n minus 1 alpha sine alpha cos n theta, because we require sine alpha minus n theta in the answer, so we will add cos alpha sine n theta, add this quantity and subtract this quantity, cos alpha sine n theta plus minus iota sine alpha sine n theta. So rewrite sine n minus 1 alpha. Now this is sine a cos b minus cos a sine b. So this is sine alpha minus n theta. Okay, now adjust this term with this one. Okay, so you can write this as cos alpha sine n theta plus minus iota sine alpha sine n theta. Okay, so now sine n minus 1 alpha sine alpha minus n theta. Okay, now you can take sine n theta from this expression, sine, take n theta common, then what you are left with, cos alpha plus minus iota sine alpha. Okay, now so this is sine n minus 1 alpha sine alpha minus n theta plus this expression in the bracket, you can write this as e raised to power plus minus iota alpha, and this is sine n theta. So this completes the solution of this question. Okay students, so next we move to question number 3. Again, start from the left hand side. What is the left hand side? Sine alpha plus theta minus e raised to power iota alpha sine theta raised to power. So again, open in the same way. First apply the formula for sine alpha plus theta, that is sine alpha cos theta plus cos alpha sine theta minus e raised to power iota alpha, you can write this as cos alpha plus iota sine alpha, and this multiplied by sine theta raised to power n. Now open the quantity in the square bracket, sine alpha cos theta plus cos alpha sine theta minus cos alpha sine theta minus iota sine alpha sine theta raised to power. Now you can take sine alpha outside, sine alpha. Okay, what you are left with, cos theta minus iota sine theta, and this whole raised to power n. So this will be sine n alpha, and the expression in the bracket is e raised to power minus iota theta, and this is raised to power n. So you can write this as sine n alpha e raised to power minus iota n theta. So this completes the solution of this question. Now we move to question number 4. So here is question number 4. Again we will start from the left hand side. So what is left hand side? Sine alpha plus n theta minus e raised to power iota alpha sine n theta. So again apply the formula, sine alpha cos n theta plus cos alpha sine n theta, and you can rewrite as e raised to power minus iota, e raised to power iota alpha as cos alpha plus iota sin alpha multiplied by sin n theta. Sin alpha cos n theta plus cos alpha sin n theta minus cos, open the bracket, cos alpha sin n theta minus iota sin alpha sin n theta. So cancel cos alpha sin n theta here and this one. So what you are left with, sin alpha common cos n theta minus iota sin n theta. So this is sin alpha e raised to power minus iota n theta. So this completes the solution of this question. Okay students, so that's all from today's lecture. In the next lecture we will do some another topics from circular and circular function of complex variable. Okay, so stay tuned for upcoming lecture. Thank you.